Okay, here are your notes for transformations. It is my memory that the notes are kind of confusing, but then once you get to the homework, it's really easy. So if you have some questions, try it out on the homework first. And if we need to do a Google Meet, we'll do a Google Meet. Okay. So basically, we're going to be moving graphs around, reflecting them, stretching them, and all sorts of things. So the first thing you need to know are the mother functions, okay? So the first one is the identity function, y equals x. So you can copy that down. You know y equals x squared is your quadratic, your parabola. The square root function is like half of a parabola. This is your cubic function. This one is a new one, the cube root of x. You'll want to put that in your notes real quick, the cube root of x. Um, the reciprocal function also might be a little bit new for some of you. Looks like this. And then the absolute value function, which looks like this. And basically what we're going to do today is we're going to be moving these, and you should have a lot of experience with this from the parabola. Remember, we used to write our parabola like this, and we can move it up and down. You can move it left or right, and it could be smiling, it could be frowning, all sorts of things. So that's kind of what we're looking at today. So when you move them, when you move a mother function around, we call it a transformation. So when you move a function, it is a transformation. Okay, so you'll want to write that down. And there are lots of ways we can move it. So the first way we can move it is you can move a function up or down. So how can you tell if it's up or down? Basically, for all of those things, if you take your f of x, whatever your mother function was, and you add a number to it, a lot of times we say k, but here they put b, this will move it up b units. Okay, if it said minus b, it would go down b units. So it's outside of the parentheses. It's really important that you know that it's outside of the parentheses. And that moves it up or down. So the example that I want to talk to you about, they did here is x to the fourth, and they moved it up 5. So they took the mother function that they started with, which had a little stretch to it, and they just moved it up 5. When you had parabolas, if it was x squared plus 4, it went up 4. If it was x squared minus 7, it went down 7, but it was still the same parabola. Now, sometimes kids think that one is bigger than the other, and that's not true. These are the exact same size, but whenever you can't see the whole graph because your window is different, it kind of looks smaller, but they are the same size. So vertical is the up or down, and it's outside of the parentheses. Next, we're going to go left or right. Horizontal, that's left or right. And what happens there is you put something in parentheses, and you do the opposite of what maybe you think, opposite sign. So what do I mean? I mean that if it's in parentheses and they're using a D here, if it's x minus D, you think minus is usually to the left, but we're going to go to the right D units. If it's a f of x plus D, you're going to go to the left D units. And you have practice with this with your parabolas as well. When we had parabolas, you would have things such as x minus 3 squared, and you would start your graph to the right 3, and that's where your parabola would be. So here, they have a plus 7 in parentheses. So they took their original guy and they moved it to the left 7 because it's the opposite of what you think. Okay, so if you go to the right D because it's a minus, or if it was a plus, you would go to the left D. Reflections are when you flip it over the x-axis. And how can you tell that? Well, there will be a leading coefficient. And usually, this is what's the tricky part, the x-axis or the y-axis. If the negative is in front of the function, it flips upside down. So that's the x-axis. If the negative is in parentheses, Technically, you don't have any experience with this. It will reflect over the y-axis, but you'll be able to tell based on the math lab questions, okay? So if a point xy is on this graph, x negative y, it just flips over the bottom. If it was in the parentheses, then it changes the x. So this one, what does this mean? This changes the y, and this one changes the x because the x is changed, and this one, the whole y is changed. So they're going to give us an example to look at here. Of what happens. Okay, so I guess what they're going to do is this is our original function. And since the negative is in the parenthesis, they want you to change it over the y-axis. If the negative was in front, it would be over the x-axis. Sorry, I was stuttering here. So here is an example of the black graph is the original. And because the negative x was in parentheses, the new graph is now the red one. So it went over the y-axis because the negative x was in parentheses. If the negative was in front, the black graph, it would have just been flipped upside down so that it would have looked kind of like that. It's not very good, but you get the idea. I'm sure they'll show you an example right here. Yes, here's the negative in front. So when the negative is in front, there is the black graph, and then it just flips over the x-axis. So if negative is in front, it flips upside down. And I can go back here. If the negative was in the parentheses, it flips left to right. Vertical stretch and shrinking. We used to call this a stretch factor, and this is also a little bit confusing, but it's not super bad. If there's a number in front, if it's in front, we call it a vertical stretch. And that's what you're used to seeing. Y equals 2x squared is a vertical stretch. If the number is between 0 and 1, we call it a shrink. Okay, a stretch if it's bigger than 1, a shrink if it's less than 1. So y equals 1/2 x squared, we call it a vertical shrink. So that was a wide one. So I want you to think about it. From the top, if somebody was sitting on it, it would make it flatter. If from the top 2x squared is skinnier, it's like somebody would be pulling it or stretching it. Okay, so vertical, from the top they're pulling, or from the top they're pushing. If it is inside the parentheses, that will be a different story. So here, look, the number is in front of the parentheses and it's less than 1. So it's like somebody is sitting on it and it flattens it out. So black is original. They're sitting on it. They're flattening out. That is called a vertical shrink. If it was a bigger number like 2, they're pulling from the top and bottom. It makes it a stretch. Here is a -2. A -2 flips it upside down, first of all, because of the negative, and then it stretches. So that's a combo, a flip upside down because it's in front and it stretches. Horizontal is kind of like an accordion if you want to think about it. It's called a stretch if it's between 0 and 1. So they're stretching it and they're shrinking it if it's bigger than 1, because horizontal is always opposite of what you think. Remember, the left or right? So if it's a small number, a fraction, it's actually a stretch. And if it's a big number, it's actually a shrink. So what will this look like? The number will be right inside the parentheses. So 2 is inside parentheses. So it's opposite of what you think because it's inside the parentheses. And they took that black graph and they squeezed it in from the sides. They're shrinking it from the sides. Here is the 1/2 on the inside. It's opposite of what you think. 1/2 is a small number, but we're going to make it bigger by stretching it on the x-axis instead, like an accordion. -1/2, first the negatives in the parentheses. So that's why they flipped it over the y-axis first. And now because 1/2 is a small number, it's going to make it bigger and they're going to stretch it. Okay, and that's all I have. I know it's just kind of some putting some things in notes, but I think the problems in the math lab will make more sense for you. But if you need help, we'll do some of them together. We'll make a Google Meet.